study about variations. Now we have four kinds of variations. We have the first one, which is the direct variation. The second one is called the indirect variation or the inverse variation. The third one is a joint variation. And the fourth one is a combined variation. So, what is this variation class? Why is it different from ratio and proportion? In ratio and proportion class, we have also the direct proportion, which is from the direct variation. We have also the indirect proportion, which is also from inverse variation. In ratio and proportion, we have already our formula, and we are going just to substitute the given result for that. In variations class, we are the ones to make the equations. So we have to make first it in symbols, and then in equations, and then we find the constant k. So let's start here, class. To identify whether that is a ratio and proportion or variation, you will see varies, proportional, directly proportional, or inversely proportional, varies inversely in variation problems. So you will know if it is a variation problem if you will see them proportional, inversely, directly. Okay. So we have here for the direct variation class. Direct variation means if the first quantity increases, the second quantity also increases. In inverse variation, that's the opposite. When the first quantity increases, the second quantity decreases. Or if the first quantity decreases, the second quantity will increase. It's just like one is increasing, the other one is decreasing. It's like this. In direct variation, they rise at the same time or they fall at the same time. Okay? So let's have this one, direct variation. So first, we will write this in symbol. So what is the symbol for this? Y varies as x, or y is proportional to x, or y is directly proportional to x. Okay. So there are so many ways of saying the direct variation. So in symbol, we write first the first letter here, which is y. The symbol for varies, whether that is direct or indirect, is the symbol. And then if it is proportional, if it is direct, then we write here the letter, the last letter as x. So we have here in the symbol y varies as x. Y is directly proportional to x. Y is proportional to x. This is in symbol, the direct variation. Now, after writing that one in symbol, we will write that one in equation. When we have our equation, we need to introduce our constant k. This y, of course, is still y. When we transform the symbol into equality symbol, we need to put our constant k. And then afterwards, we write our x. So in symbol, this one is our in symbol of our direct. In equation, that is y is equal to kx. Then we solve for the constant k. So we divide this by x, we divide this also by x. So our constant is equal to y over x. That's why in our ratio and proportion, you will see there A is to B as C is to D. That is division. And this is our constant. Okay, let's have the inverse. Now, in inverse variation class or indirect variation, we have this one. Y varies inversely as x, or y is inversely proportional to x, or y is indirectly proportional to x. So first we write it y, because that is y. If that is a varies as b, you use letter a. Y, and then the symbol varies, still the same, but this time instead of putting that one here, the x should be 1 over, or the reciprocal of x, which is 1 over x. If x is up, that is direct variation. If that is the reciprocal of x, that is the inverse variation. It's like up and the other one is down. We change the symbol to equality symbol. Then we introduce our constant k here, multiply to 1 over x. So we have 1 over x like this. Now when we multiply this, it will give us y is equal to k over x. To solve for k, we just cross multiply. So our k here in inverse variation is k is equal to x times y, or y times x. So in inverse variation, we have multiplication. X sub 1 times y sub 1 is equal to x sub 2 times y sub 2. The other one, in direct variation, is different. Y sub 1 over x sub 1 is equal to y sub 2 over x sub 2. Okay, class, so let's have example number 1 of direct variation. So we have here y is directly proportional to x cubed when x is equal to 2 and y is equal to 32. Find the value of y when x is equal to 5. So first, forget this one and let us concentrate ourselves here up to that y is equal to 32. First, we write it in symbol. We know it is directly proportional, or this one is a direct variation. So y, let's put the y here, and the symbol of variation is that one, directly proportional, meaning we are going to write here that x cubed. So we have x cubed, same line, y varies as x cubed. Okay. Then we write it in equation form. So this one will become y. So we have y is equal to, introduce first the constant k. Don't forget, when we write it in equation form, we introduce our constant k. And then we write the x cubed. Okay. Then afterwards, we solve for k. How do we solve for k? We divide this by x cubed. We divide also the other side by x cubed. So we have here k is equal to y over x cubed. And that is our constant. From now on, we will use this equation class. Now we solve for k. We use x is equal to 2 and y is equal to 32. We substitute these two values in our y and x cubed here to find the constant k. So here, let us solve for k. K is equal to, what is the y there? 32. Okay. What is the x there? 2. You have 2 k cube. Okay, to continue the class, 32 here. What is 2 cubed? That is not 2 times 3 because this one is the exponent. It means that we have to multiply the base by itself 3 times. So we have 2 times 2 is 4 times 2 is 8. Therefore, this 2 cubed is 8. And finally, we divide 32 divided by 8. So our k is equal to 4. That is our constant. Next is the question now. Find the value of y when x is equal to 5. Okay, after finding this one, we substitute the k here. We go back. So we replace k by the value of k here, which is 4. So we have 4, copy the equals here, then the fractional bar, and y. What is our value for y? There's no value for y because that is the one that we are going to find. So write y here, and what is the x cubed here? The x is given now, which is 5. So we have 5 cubed. Okay, so let us first raise 5 to the 3rd power before we cross multiply. 4 is equal to y here, and that 5 means 5 times 5 times 5. So 5 times 5 is 25 times 5 is 125. And what is this one? It's very easy. You can use cross multiplication to solve for y. Multiply 1 to y. 1 times y is y. And 125 times 4 is 500. And that is the value of our y. And that is how to solve this direct variation problem. Okay, we'll have another example of this direct variation. Okay, number 2 example class. We have this one. We have the speed of water in a river is determined by a water pressure gauge. This is a manometer. The speed V in meter per second is directly proportional to the square root of the height h in centimeters reached by the liquid in the gauge. Given that h is equal to 56 centimeters when the speed is 8 meters per second, calculate the value of V when h or height is 18 centimeters. So let us first write that one in symbol. So we have the V here. We have the symbol whether that one is directly proportional or inversely proportional to the square root of the height. So how do we write the square root of the height? So we have symbol of square root, and then we have the height. So this is our symbol for that problem. Now we will write this one in equation form. So we have V or speed is equal to, we introduce our constant K, then we have the square root of h. Afterwards, we solve for K. So we divide this by square root of h. We divide also the other side by square root of h. Then our K is the speed of V over the square root of h. Now we substitute the value of V, first one there, and the h. The V here and 8 here. So we have here. So I'm just going to continue class here. The V is 8 here. And we have the square root of 36 here. Okay, so we have K here is 8 divided by the square root of 36, which is 6. And here, let's get the lowest term. So 8 over 6 is 4 over 3. So we're going to use 4 over 3 instead of the decimal. Okay, that is our K. Now again, what are we going to do with the K? We substitute the value of K, which is 4 over 3 in this equation form here. So we have 4 over 3 for K, 4 over 3 here, and then equals where? And then V. What is the V? So we are going to calculate the value of V. Therefore, we are going to put here the V because we don't have the value for the V. And then we have the square root of 18 here. We cross multiply. So we multiply square root of 18 to 4 here. Don't multiply any more than 3 with a V there. Because after you have multiplied that one by 3, you will just remove again the 3, you divide it again, and the 3 will be here again. Okay? So we have 4 square root of 18 over 3 is equal to the speed V. And then get the square root of 18, which is, let me flip it class. Put the V here, and here to the 4. And the square root of 18 class is times 4.243 over 3. So just multiply 4 times 4.243 equals divided by 3, and our speed V 5.66 meter per second to 3 significant figures.